Welcome to homework.
So in this problem, we have a person jumping from a canoe onto a dock. But for some reason, the person does not reach the dock, even though it looked very close, and the person just falls onto the water. So what is happening over here? So we know that the momentum initial, once the person is on the boat and on the canoe, and the canoe is just resting on water, we know that the initial momentum initial is just going to be equal to 0 because nothing is moving. By law of conservation of momentum, we know that the final momentum also has to be equal to 0. So once the person jumps, he gets a momentum, but the boat also gets a momentum. So if we see the final momentum, the momentum final is going to be equal to the momentum final is going to be equal to the momentum of the person plus the momentum of the boat. Since we know that this momentum final is 0, we can just pass it on to the other side, and then the momentum of the person is going to be equal to the opposite of the momentum of the boat. Then we can use our formulas for the momentum, and we get that this momentum is going to be the mass of the person multiplied by the velocity of the person, and here it's going to be equal to the negative mass of the boat multiplied by the velocity of the boat. So instead of jumping with the full velocity that the person expected to be jumping, the boat is also going to be moving in the opposite direction that the person jumped. We see that by this minus sign over here. So the velocity of the person is going to be equal to the ratios of the masses of the boat and the person multiplied by the velocity of the boat. So we see that the fastest the person jumps over there onto the dock, the faster the boat is going to go on the opposite direction. So even if it looks like it's close, once the person jumps onto the dock, the boat is going to move away from the dock and is going to make it seem like the jump was just not as far as you would expect.